Today let's start with an example of the two-stage dividend discount model. The value of a financial asset is the value of a financial asset at time 0 today is the sum of all future cash flows generated by that asset discounted by some discount rate, which is the required rate of return on that financial asset, reflecting as risk, say K. And since the firm or we assume the cash flow is the firm. We assume the firm as an ongoing basis. You will get a cash flow to the infinite period of time. So your time period is from 1 to the infinite period of time. And when we invest in equity, the stock, we expect to get either dividend and earnings from that stock investment. So if we assume this is a stock investment, you will either get a dividend and a earnings. But these earnings are the accounting concept. In finance, we measure earnings as a cash flow basis, such as free cash flow to the firm or the operating cash flows. Anyway, we're doing the dividend discount model, so we assume the cash flow as a dividend. So we measure cash flow as the dividend. So again, the value of a stock is the sum of its future dividends discounted by the discount rate or the required rate of return on that equity. Okay, let's draw a timeline. So if you invest in stock at time 0, you are expecting to get dividend from year 1. So you will not get the dividend at time 0. You will get a dividend from year 1 to the infinite period of time. Okay. And if the annual dividend payment, this annual dividend payment is constant forever. Say the annual dividend payment is constant forever. So the dividend at time 1 and the dividend at time 2 and dividend at time of forever is constant, the same, does not change. How do we value this series? We know that we can apply perpetuity method. Right? So if the future payment is constant, not change forever, the value is the future payment divided by the discount rate. So this is perpetuity. We have talked about it last class and in the financial management class. So you should be aware of it by now. If you don't, you can simply put perpetuity on the internet and go search for the simple explanation again. Anyway, what if the future dividend payment is not constant? And change, not constant and change. How do we value those dividends? Say, let's assume that dividend payment will grow at some growth rate G. Okay, so dividend is not constant and will grow at the growth rate G. Okay, so the dividend at year 1 is equal to the dividend at time 0 times 1 plus growth rate, right? And the dividend at time 2 is equal to dividend at time 0 times 1 plus g to the power of 2, which is d1 times 1 plus g, right? So the present value of those future dividend is equal to, say, the value of that stock at time 0 is equal to d1 over 1 plus k, 1 plus d2, which is d1 times 1 plus g, right? d2 over 1 plus k 2 plus and so on, d to the infinite period of time and 1 plus k to the infinite period of time. And let's assume that the growth rate g is constant. Okay, so we can rewrite this as d1 over 1 plus k 1 times 1 plus 1 plus g over 1 plus k, right? Plus 1 plus g to 1 plus k 2 and so on, right? So if you multiply this, dividend 1 d1 over 1 plus k to the power of 1 plus dividend at time 2 times 1 plus k at time 2, right? So if we look at these terms in the parentheses, what does it look like? These terms. So we can rewrite this equation as this, and what does it look like? These terms in the parentheses. It's called, maybe you're aware of this infinite geometric series. So if we apply the infinite geometric series, the sum, let's say the sum of these terms is equal to, if we apply infinite geometric series, is equal to 1 over 1 minus q, where q is this ratio, 1 plus g over 1 plus k. So if we rewrite this, the sum is equal to 1 over 1 minus 1 plus g over 1 plus k. So if we solve for this, 1 plus k or 1 plus k minus 1 minus g. So it becomes k minus g over 1 plus k. So 1 over k minus g over 1 plus k is equal to k minus g 1 plus k, right? So this term, if we apply the infinite geometric series, this term is equal to this. So the value of a stock at time 0 is equal to d1 over 1 plus k times, this is times this one, 1 plus k over k minus g. So if we delete this, the final term is d1 over k minus g. Okay. So So here, the previous page, how do we... Okay. So let's get back to our example. Okay, let's get back to our example. Okay, so D1, if the growth rate is constant, the value of an stock is equal to D1 over K minus G. This is called a Gordon's. Gordon is a professor in finance. Gordon, Myron Gordon. Gordon's constant dividend So this model, if we assume the growth rate will grow at a constant growth rate, this model is called a Gordon's constant dividend growth model, or Gordon's constant dividend discount model. Okay. Anyway, let's get back to our example. And if there are two growth rates here, 20% and 3%, at two different stages, the value of stock at time 0 is equal to the 1 over 1 plus k plus the 2 over 1 plus k. Let's draw a timeline again. Okay, so D0, let's assume D0 is $2. D0 is $2. And this dividend will grow at 20% at year 1 and year 2 and year 3. And from the year 4 and to the infinite period of time, the growth rate will reduce to 3% and will remain constant forever. So if you buy a stock at time 0, the value of a stock is D1, which is $2 over times growth rate at time 0. So 1 plus 0.2 over 1 plus k at time 1 plus D2. What is D2? So this is D1. Okay, so D1 times 1 plus 20% is 1 plus 0.2 to the power of 2, right? So this is D2, dividend at time 2, over 1 plus k squared, right? Plus, what is D3? D3 is equal to 2